I am Jillian Rowe. I am a bioinformatics infrastructure consultant, and today we are going to talk about deploying RShiny on Kubernetes using AWS and Terraform. So this is the project over here. You will see that it is in a folder called blog posts, and that's because I have an entire series on deploying RShiny on AWS all the ways, or not all the ways, there's like a million ways that you could deploy it, but probably the most common ways that you can deploy it. And today we are specifically talking about this RShiny AWS EKS with Terraform. So EKS is the Elastic Kubernetes Service that is specifically supported on AWS. It has pretty great support. I've really been getting into it lately. I think it's a really great service, and it's a very robust way of deploying things. If you are in kind of the DevOps or deployment space at all, you will know that Kubernetes is kind of taking over the world, and there's a lot of support for it. There's a lot of people building things that integrate with Kubernetes. There are a lot of people building specific packages called Helm charts that are deployment recipes for deploying your applications on Kubernetes. So all in all, for a long time I was kind of very into Docker Swarm, and I was resistant to using Kubernetes, but I had to get over that, and here we are. So this is the directory structure that I use most often, if you're wondering about it. First of all, I have my .aws. This is like my home.aws. It has all of my AWS credentials. I like to keep this per project because I work with a lot of remote clients, and each one of those clients generally will give me a different AWS credentials. I don't want those just all thrown into my home directory. I would never be able to keep track of that. So I have it per project in my AWS, and then I have the actual project folder. This is the code. So this has our Terraform code that we are then going to use to deploy our RShiny, or to deploy our Kubernetes cluster. And then once we have our Kubernetes cluster up, we are going to use Helm to deploy a Helm chart that I wrote, or that I used the Helm CLI to first kind of bootstrap for me, and then I edited that, and then we are going to deploy our RShiny application. So let's go right ahead and get started. I personally do not like to install CLIs to my local computer, with the exception of like my nice IDE that does all of my nice auto-correcting for me. But except for that, I really don't like to have too much stuff installed on my computer. So I have Docker containers. Usually I have a Docker container per project. Sometimes I'll share them a bit. It doesn't like really matter that much in this case. But you'll see I do the Docker run, and then I just bind the volumes, and I have the .aws is in there as .aws. I have a .aws cube is root.cube, and then just the name of the container that I built. I will link to that below. I do think it's handy if you want to follow along and you don't want to install all the CLIs to your local computer. That's, just use the Docker container. It will be fine. And I'm gonna go to cd project. I did that one a little bit funny. And what we're gonna do here is we are gonna go to Terraform State. Actually, you know what? Okay, so we're gonna run Terraform init, Terraform refresh, and Terraform apply, because this will take a few minutes. So while this is running, we're gonna talk about things and revisit this. So one thing that I want to talk about is just like an extremely, extremely brief introduction to Kubernetes. I know a lot of people are probably gonna come back at me with this like, oh my God, you're completely oversimplifying things. I am completely oversimplifying things, and I'm totally fine with that. But anyways, every time you have a computing project, especially like a distributed computing project, I imagine that you're here because you need some kind of distributed RShiny, you need it with a load balancer, you need more power, more file systems, you need more something than you're getting with your other deployment. If you don't, I don't really know exactly why you would use Kubernetes. It's probably more trouble than it's worth, but maybe you just want to learn something new. So anyways, with Kubernetes, as with any computing project, what you have is you have your data persistence layer. This is a file system. Sometimes you can kind of think of it as being also something like a database, but even a database is eventually going to write to a file system, and that is actually where your data persists. So you have your data persistence layer. Kubernetes calls those PVCs, which are persisted volume claims. You have your compute layer. These are the physical computers. These are servers. These are, if you've ever been in a data center, like the servers, that's what the compute layer is. Kubernetes calls those pods. I don't really know why. It always makes me think of like some science fiction pod people, but that's fine. Pods is a fun name too. And then on top of your compute layer, you have your application layer. Your application layer is, in this case, RShiny. We are deploying RShiny. That's our application. That application is going to sit on one of our pods. It does actually have to physically exist somewhere, but the idea with Kubernetes is that there should be kind of an abstraction. You should be able to set up sort of a series of rules, and then you don't have to care so much exactly where your application is physically sitting. So that's why you have that divide between the application and the compute layer. And then on top of that, you have your services layer. Your services layer is, if you've ever worked with a firewall or anything, or a network, or even if you've just deployed a web server and just had to access it through a particular port rather, that is your services layer. That is what allows your application to talk to the world. In the Kubernetes kind of context as well, that will often take care of load balancing, which is just getting a public IP address for your service. If you've never heard of load balancing before, that's fine. Don't worry. It's just a little layer that sits between, here's the world, here's your application. You need a layer between that says, okay, this is how I'm going to route traffic to my application. So, now we're back. Now we're going to do our setup with Terraform and the Helm chart. Just to very briefly go over Terraform. Terraform is an infrastructure as code framework. I guess we'll go with framework. And what it does is that it takes all the different building blocks of infrastructure and it maps those. I'm not sure if it's classes or objects underneath the hood, but probably classes anyways, where say you have, let's go with an EC2 instance, an AWS EC2 instance, right? What does this have? It has the ID, it has the, what kind of instance it is. Is it the Ubuntu instance? Is it the Amazon Linux 2 instance? I don't even know what all, the VPCs that you want for that, all the kind of things that you would normally go through to use to actually set it up. If you were going to go on the Amazon Web Console and say, I have an EC2 instance, what do I need with this? I need to know the type of instance. I need to know the root volume size. I need to know what VPC I want it deployed in. I need to know what subnets I want it deployed in, maybe. Actually, that one is a little bit sketchy with subnets. With my knowledge of subnets anyways, I really hate networking and I try not to do it. So anyways, so what you do is you take those individual building blocks and then you take those and you compose them into something larger. So that is exactly what we're doing, and in a minute we will go and we will look at the code. It's just that for right now you can see, this is the layout. This is the layout. This is exactly what I explained before. And we just did our Terraform state, so let's go and let's talk about that. Okay, so Terraform, in addition to being an infrastructure as code, one of the things that it keeps track of is it keeps track of this thing called your state. Your state is, what steps have I done? Which ones worked? Which ones didn't work? What resources did I create? What are their IDs? Things like that. This is your state. It's a bit like if you've ever used a makefile, and your makefile, it will go through the steps, and if it sees the file that it already created in a previous step, it won't re-execute that. So you run make thing, and it will go through all the steps, and then you run make thing again. It's not going to completely rerun them all over again. So this is our Terraform state. This is something pretty standard. This is just telling Terraform, I want to actually save my state to AWS instead of saving it locally. The default Terraform state is to just save it locally, to a file, and I'm telling it no, I want to save it to AWS. And I am doing that because, as a bit of future-proofing actually, in case I want to share this with other people, they cannot be writing to a state that only exists on my file system, right? They can't do that. So instead we have a remote state, and that will also prevent multiple processes or multiple people from clobbering the infrastructure at the same time. So this is good. This is good to have. It's pretty straightforward. You can find it all over the place. What does it create? It creates an S3 bucket. So here's exactly an example. We have a resource. A resource is something that we want to deploy on AWS. We want an AWS S3 bucket. We give this a name. This is a name for us and a bit for Terraform too. This is, if you were going to call this, a key value kind of thing, this would be the key to access this. And then we give the name of the bucket, we assign the ACL, we assign the region, we say that we want versioning enabled, and we say that we want the tags. And then also, I'm not totally sure why Terraform wants this, but it wants a AWS DynamoDB table. And so we will create that. DynamoDB is the AWS key value store. So we have that. And I did run this. I ran Terraform init, Terraform refresh, Terraform apply. And you can also see here, so green is good. Green is always very, very good. In the instance of Terraform, it is especially good. So we have all these things, and then we have apply complete. But you can also see exactly what it created down here. So this is good. So now we're gonna head up one directory, and we're gonna go, what did I name this? I named this EKS. All right, so then we're just gonna run the exact same command again. And I'm gonna really hope that this works, because this is live coding right here. I haven't even run this one before. I ran the init command while I was sitting and waiting for something else. Okay, so you can see that the first thing that it does is I am actually downloading some modules. If you haven't taken a look at this yet, I really recommend going and taking a look at the Terraform AWS modules. What the modules are, it's like a cookbook of recipes that has a lot of convenience kind of functions and convenience AWS building blocks that are already put together for you. So for instance, in this post YouTube madness, I am using the EKS module, and I'm also using the VPC module, and that is because these are very common things to do, and I don't want to do them all myself because that's kind of a pain, and I'm kind of lazy. So here we go. Oh no, I forgot about this. Oh, I might have to kill this video. We'll see. Did I not put the state, or did I not put the region? var.region. Well, yep, I forgot to change the region. Okay. We'll see if it works. I don't actually care if it gets deployed in this region. That's fine. Oh, you know what? Actually, I didn't do for this one. I didn't say that I want to save the state remotely to AWS. Okay, I will update and I will show how to do that. But for right now, I'm going to create this. I'm going to kill it as soon as this video is done. So this is fine. Anyways, you can see like there are lots of things being created here, right? There are lots and lots of things. So many things. Here we go. Module EKS. It's creating the policies. It's creating the VPCs. It is creating, what else is it creating? The route tables. Yeah, so Kubernetes is really, it's a beast to try to get installed if you try to do it yourself. Initially, when it came out on AWS, they had this really like long tutorial for all the steps that you needed to follow to make the policies and to make, the routing tables and make all of these things. And it was a huge pain. It was very, very painful to do it. And then another tool, EKS CTL, came out. I have another video on that. I'll link to that below. That was a pretty good tool, but I think overall I kind of just like to use CloudFormation or Terraform as the case may be. I tend to go with just whichever one has what I want in it. So there are other times where I use CloudFormation because it already has like what I want. It's included as a recipe there, and there are other times that I use Terraform. I have no particular brand loyalty. Okay, so actually this is going to take a little while, but as this is going, what we're going to talk about here for a minute is the Helm chart. And if you'll remember, what I said is that the Helm chart, it is the recipe for deploying our application. It is specifically the application layer. So now what we are dealing with is we are dealing with kind of the infrastructure layer. We're having Terraform deal with deploying the Kubernetes cluster itself. So once we have our cluster deployed, what we want to do is we want to deploy our RShiny application. So this is the Helm charts, RShiny EKS. And we are just going to kind of briefly we are going to briefly talk about this. I'm going to minimize this so you can see it's just going. It's going to take a little while, so we're going to talk about this instead. So if you haven't ever seen a Helm chart, it is made up of a combination of YAML files, and that is because that is the default kind of format that Kubernetes reads. What you do is you create different configurations for these different layers that I was talking about. And what you have is you have one values, you have your initial values.yaml here at the top. I'm going to close this out so that you can see this a little bit easier. But see, what we have here is we have our Helm chart. This is the Helm chart that I have, RShiny EKS. And we have lots of things in here, but one of the things that we have is our chart.yaml. That's like your, of course now I can't think of it, but the kind of the definition. This is our chart definition. This is like our package.txt if you've used kind of other package managers. So this is RShiny EKS, and that's all. This is just the default because I just used this. I did this doing the Helm. I think it's Helm init or Helm create. It's Helm create. And then what Helm does, that's actually pretty handy, is that it creates all the templates for you, and it also creates you this values.yaml. And the values.yaml, what it has is it has all of your default values that are going to be pretty good going forward. But also what it does is that it exposes these values.yaml through the Helm API, which is really, really neat. So you can actually change anything in the values.yaml. You can change that on the command line when you deploy. And I'm going to show that in a little bit. But one of the things that you could do is I have this image repository, and I'm just using the default RShiny because for my particular instance, this doesn't actually matter. But you would want to actually upgrade this with your actual RShiny application that you are deploying. I have this container port because the Rocker Shiny image, it runs on port 3838. Not sure why it does, but it doesn't really matter either. I also have the replica count. So for instance, with this particular application, this is just a demonstration application. I only need one replica, but there's a good chance that if you're deploying with Kubernetes, that you want to have lots of replicas. And that's why you're deploying with Kubernetes, right? You have the tag. You have these other things. I would recommend just keeping these the same. You have your service type. And then you have your ingress. This gets a little bit interesting. What you can do is you can actually deploy, it's called having like a microservices architecture on Kubernetes. And you could have many, many, many applications, and then you could control how those are accessed with the ingress. So what we have here, yeah, we have the ingress. I've enabled it. I am saying use the Nginx ingress, which is probably the one that I most kind of use now. I'm gonna look into using another one called Traffic soon because I really liked that one for Swarm, and they've kind of upgraded to Kubernetes. And then you have your hosts. What you want here, you probably have an actual domain name that you want to point to, so you would point to that. And this is going to be, we're going to go over this when we actually deploy this, but this is the host. This is the host name that AWS gives you back. So normally what you do is you deploy with your Helm chart. AWS is going to give you a public DNS address. And once you have that, you would update this. You would update your ingress to use this public address. And then you would go into your hosting panel and you would have this domain name point to this thing, and it's so much networking, but you'll see it in real time, and I'll show it to you and it will be fine. Okay, so then we have that. So these are all of our kind of exposed values, and you can edit this as well. You can add whatever you want to this. Like you could be like MongoDB, like you could have whatever you want in here. I don't know what happened there. And the templates. Okay, so then we have our deployment. And you can see here, Helm uses this kind of templating language. I think the backend is written in Go, but pretty much there are a lot of these kind of include statements and then these indents because YAML is such a pain. It's such a pain about indenting. And I understand why it's a pain about indenting, and it is kind of nice because you get all this code folding, but it's still pretty painful. Anyways, then what you have here went on a bit of a tangent there. Anyways, we have a deployment, which is we're actually deploying. This is our application layer. There's a couple different ways that you can deploy your application layer. The default is to use a deployment. That's fine. And then you have some nice metadata. This matters when you're getting into really kind of like complex deployments. For now, it doesn't really matter. You have your spec, you have the replicas. In my IDE, I actually have like a Helm, I don't know what, Helm like helper, I guess. And so these values are kind of, unless I click on them, it shows what's actually in the values, which is kind of handy because then I know what's actually happening in my chart. Although it doesn't seem to happen all the time. Like here, it doesn't happen. I don't know. But you can see for this one, this is what my IDE shows. It shows the kind of interpolated value. So this is the chart name. This is the image. This is the image repository and the image tag. I do just kind of want to point out one thing that I find to be really annoying, that nobody ever actually uses this, it seems like, out in the wild. But the default tag for your image, it's actually the version in the chart. So it would actually be, this version. So that's just something to watch out for. That's one of these things that's gotten me a couple times, that I forget to go and change the image tag. On almost any Helm chart that you'll find kind of out in the wild, this image tag is exposed in the YAML, just like I did here. So just something to keep in mind, just something that you'll see. There we go. So we have the containers, and then the next part here is we are going to talk about the ports. So like I said, the container port is 3838. That is the application that is running within the Docker container, and that's the port that it's running on. So this is pretty important to know. Depending on your application, it's going to be running on a different port. This is our port here. Obviously, if the application in your container was running on like port 80 or port 8080, you would change it. You would change the container port to whatever is appropriate for your context. And then actually what this gets mapped to, can I open this? Could I open this like, okay. So you'll actually see, this is a bit funny, the way that this is done in Kubernetes. So then this is our service, and if you remember, our service layer is the way that our application talks to the outside world. And what this does is this maps from this thing here that we have, this name. So this is our metadata name. This is the name of our service. This is the name of our deployment, which is what we are using as our application layer. And these are the ports. And the ports are like primarily how we talk to the outside world. When we talk about services, we're talking about a couple things, but like on a really simplistic standpoint, we're really just talking about ports. So we're gonna say here that this port, it has a name and it has a protocol. Usually your protocol is gonna be TCP, so don't worry about that. But you'll notice here that the name is HTTP. If you are deploying a lot of containers, like you're using Kubernetes as a microservices, you will want to like give this a more descriptive name. Don't use HTTP. Okay, give it like a real name, RShiny or something like that. I left it as the default because it's fine. I don't care. So then you can see here, my whole tangent about that was that you can see that the target port is HTTP. This maps to this. So if I change this name to RShiny no, don't put a dash in there, but RShiny, then I would change it here to RShiny HTTP. Okay, I'm gonna leave it. I'm just gonna leave it, but I'm just showing you there, I just wanted to show you how these things map because it does get to be a little bit tricky. I always used to do this when I first started out with Kubernetes. I was like trying to figure out how to go from Docker Compose and Docker Swarm to Kubernetes, it was kind of a flawed plan to begin with because they're not like adjacent technologies, and there's this tool called Compose, which is really great. It's a really great tool, but one of the things that it does is it tries to do this direct mapping from Docker Compose files to Kubernetes, which like it mostly works, but there's a couple of little funny things, and this was one of the little funny things that I found transitioning from Docker Swarm and Docker Compose to Kubernetes. Was there was some point where this really tripped me up. So now I'm passing on that knowledge to you guys. Now you can know where I got really tripped up, and that was on the stupid port names. Why can't, like, it should just be a single port, and then it should just map, you know. But I get why they did this. It's because then you can have this nice separation of responsibilities between the service and between the application. So in the Kubernetes world, no, it shouldn't be that simple. It should be, you have your service, you have your application, these are different domains, and they remain separate. And then, what is this? This is the ingress. This is pretty much what we talked about. It is the real, like, okay, how are we talking to the outside world portion of this application? And that's that. That's really all that I wanted to talk about with Kubernetes. The rest of it is really kind of getting deep into Kubernetes, and that's really all that you need to know to deploy. Like, if you're just deploying like an application, an RShiny, Dash, Flask, whatever, this is it. You need to know about the deployments, you need to know about the service, and you need to know about the ingress. And those are what you need to know about. So that's that. What happened to my terminal? Here we go. Okay, so this is still going. This is gonna take a little while, so I'm gonna, as soon as I say that, right? As soon as I say that, here it is. Okay, here we go. Man, I must have talked for a while, because I think that takes some time. This one takes some time. So one of the things that I do, because I hate having to remember stuff, is that I actually have my modules, and they all have outputs, and one of the outputs that they have is to configure the Kubernetes client, and I don't think I remembered to put that here. So we're gonna go find this. Outputs. Yeah, kubectl config. Where is it? See, now I have the way that I usually do things, and then I have like minimal examples that don't have a ton of stuff that is only for me. But then I realize I kind of need my ton of stuff that's only for me. See, here we go. Here we go. Yeah, I can already see this is going to be a little bit different. So as I was doing this, what I thought was like that I wanted to stay as close as possible to the Terraform example, because they have like a basic example, and it's really good. It's perfect. Like, to start off with, you should absolutely use it. Don't screw around with it too much. Don't screw around with it too much. And uh-oh, did I break that? No, I didn't break this. But okay, but kind of like additionally, secret dot ew. My computer is like really, I don't know if it's on its last legs, because it keeps kind of freaking out like this. See, like this. Like, what is it doing? It's text. Stop freaking out. All right, let's see if we can do this. You can see some troubleshooting in real time. Oh, you can actually see, so one of the things that it does do, never mind, this should be fine actually. Where's the secret? Let's find our secret. No secret? All right, this should be fine. Famous last words, right? This should be fine. We'll see. And then, actually I was a little bit stupid and I didn't change this, so we're just gonna, what was this? I don't even remember where it deployed to. Region, US West 2. And then the name. I think this was the name. Actually, no, I don't know that we need this. Yeah, this is fine. I didn't actually know. Okay, so I'm pleasantly surprised. So normally what I have is I have something that I thought that I had to have that would output my kube config, and as it turns out, Terraform was doing that for me already. So I was doing extra work for myself. But I will show you this just because I think that it's pretty handy to do things like this. And then I'm going to show you the fun thing on the Terraform page. But anyways, so what this is a resource. This is a null resource, and then I'm calling this kubectl update because one of the things that you can do within Terraform is that you can just call arbitrary bash commands, and that's really nice because you can do different things. Like for one thing, you could include tests as a part of your infrastructure, and that's something that I really like to do. So for instance, if I have, I'm deploying a database. Let's say I'm deploying a database on AWS. One of the things that I want to test is, can I actually connect to this database the way that I think that I should be able to connect to this database? And it's very nice. It's kind of like having notes for me in the future, or what is it? Somebody at some point, and I really wish that I remember where I read this because I've always thought that it was very apt, said that tests are like living documentation. And it's true, tests are like living documentation, and they are very, very important for me in 2 minutes when I have forgotten what I am doing. So anyways, so I really like to have these kinds of things here. This one isn't a test, but it's, it's one less thing that I have to remember. It is the null resource kubectl update. You can say it depends on these other things. For myself, I'll say that this always runs, and you have to add this in because, like I said, Terraform, it will keep track of your state. And if it says, oh, I've already run this before, it won't rerun this. And sometimes I just rerun things just to get these kinds of outputs. So just keep that in mind. Then this is how you would, this is how you would update the kube config. Kube config is very much like it sounds like. It's a configuration file that is then read in by a CLI called kubectl, and kubectl is what actually integrates with your cluster. It's kind of like running Docker, except instead of running Docker, you run kubectl. So then that's all of this. All right, so again, think about how you can have little things like this in here to make your infrastructure easier. Think about how you could just run a bunch of PyTest commands to test that things actually work the way that you think they are. So right now we're gonna go and we're gonna see. So then we're gonna run Helm upgrade -- install Helm charts EKS values load balancer. I think that's all that we have to set. Oh. We have to give this a name. I'm gonna give this, actually wait, let's see if this one, oh, no. Okay, so I was kind of hoping that this kubectl, that this was fine, but no, I do actually have to rerun this. I think what it is this one. No. Kubernetes Secret. Okay, so I've changed my mind on this like 6 times. Is this running? Is this not running? All right, so this did not actually configure kubectl to point to the AWS cluster. So as it turns out, I do need this. I saw this file here and I was like, oh, this is nice. This must be just fine. But no. No, 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 no. So I'm wondering why I have a Kubernetes secret and I can't like find it in my file. See, this is what I get for trying. I was really trying to just do the minimal example. But that's okay, because you guys can see me, you are gonna see me kind of go in real time here. And then this one here, it's actually named something else. So what's the name? It's locals.clustername. Does this get me any complaints? It does. It does. Let's close out some of our windows. So what I'm doing is that I want for Terraform to spit out, to update my kubectl config, and to do that I have to get some of the other outputs from Terraform from when it created the cluster. So I have a cluster, it's here, it's created, and now I have to access some of the things that I already know about it, but because I write my configurations a little bit differently than the one that I'm showing you guys, I'm having to dick around a little bit. That's fine though. Where's the name? Where was this name? See, here it is. So then I want cluster name. Ah, local cluster name. What did I have this? So this should be name is equal to local dot cluster name. And again, my IDE is freaking out. Okay, start. Oh. I was like, why does that look so strange? Why isn't it highlighting properly? So normally one kind of convention that I like to follow is, because I'm very rarely deploying just like one thing, I actually just like to give my whole project a variable called prefix, and then I will use that prefix all throughout my project. So for instance, with this one, a lot of times when I deploy RShiny, I'm also deploying, maybe I'm deploying a database, maybe I'm deploying a message queue. Quite often I'm deploying some file storage, so I'll deploy some EFS file storage, and then I can use the same name all throughout. So that's why in the default Terraform, like in this basic example, then what they use is they use this locals variable. Yeah, they use this one. So this one is the cluster name in the basic example from Terraform. Yep. And so then so instead of using var prefix, I'm just using local cluster name. That's it. That's all that I'm switching out. It's kind of like a personal preference thing, just defining your variables that then get used throughout your project. Because remember, this is infrastructure as code. Okay. And then for this one, I'm hard coding in the region because I forgot to change it, so it's in here. And then I'm gonna run Terraform init again, and we are gonna see how this goes. So the Terraform init, what it does is it initializes the environment. The refresh says pull everything from the cloud here. So if somebody else had done something to change, like you could update all the states. And then Terraform apply means, okay, actually deploy my stuff now. There is also a Terraform plan, which would just tell you what Terraform would do if you applied it, but it doesn't actually do it. So that would be non-destructive. Oh no. What you know like? What doesn't it? This isn't good. What doesn't it like here? I swear, I've used almost this exact same chart. Like, I've used it so many times, and then because you want to change just one little thing, and you want to do it live. I don't know. It's saying that it doesn't have some. I don't know why it would give it like a weird Kubernetes secret name. Although actually, we don't actually need this. Well, yeah, we need this. We need this. I don't actually know why I have this. I'm sure that it will occur to me right after I have this video, and then I'll be like, oh my god, people didn't know why I didn't have that. They must think I'm such an idiot. You don't know, the struggle is real with live coding. It really is, especially if you're doing training or something and you're supposed to like actually know what you're doing and you try to do things live. Oh, it's hard. But it's fun. It's one of the more exciting things. So anyways, I realized I don't need this one right now. I don't think I need this one right now, so I'm actually just gonna leave it out. And then I'm just gonna say kubectl update. I don't think I need the secret. It's in there. I know. So the thing is that it's in there somewhere because it gets created by Terraform, and I know that it's created in there. It's more just exactly how I'm gonna access it. But I don't need it for this one right now because I'm not putting any kind of certificates. This is for, you know, secrets and certificates and whatnot. Like certificates like SSL, like when you want to be using HTTPS and things. And I don't need that one right now. So we're just going to ignore it and just pretend that it did not happen. Okay, this is still going. I'm starting to wonder if it's going to go on long enough that I should pause the video. What I probably could have done here is I think I could have just copied this to the .cube and just been done. But I don't know. The trouble with manually copying things around is that it's too easy to like get used to it and be like, oh, it's fine. I'll just copy this thing. I'll just copy this thing. When it really should be automated. So let's see if we have anything in our .cube folder. Yep. So now we have our kube config. And let's go take a look at it. And it should, yeah. Okay, so just to go over that again, what I was doing is I was saying, okay, Terraform, create my stuff. And then I wanted to go and I wanted to access some of the data from Terraform about actually creating my stuff. And then I wanted to say, all right, now go and update this configuration file that I need to actually access my stuff, which in this case is our Kubernetes cluster. So you can see that I have this resource. It's a null resource, meaning I'm just going to execute arbitrary bash commands, which apparently really bugs the Terraform people because they're like, don't do this, don't do this. There's always other ways to do this. But I'm a rule breaker, and I like, you know, you will pry my bash and SSH from my cold dead hands. Anyways, so then you want to run this kubectl update. Because it's an AWS cluster, like AWS has a bit of a wrapper that will actually update your kubectl config. And within that, I have some variables because I wanted, I don't know, when I wrote this, I wanted to have variables. I didn't want to just have just one string here because God forbid we just have one string. And what that does is that then writes out a configuration file, and then the Kubernetes API, or the kubectl, which is the Kubernetes CLI, is going to look at this file, and then it is going to access our cluster. So now we're going to run kubectl get pods. Okay, and nothing was found, as expected, because this is a brand new cluster and we have not actually deployed anything. So there we go. You can actually see, are these are kind of, yeah, these should be the same thing. Yep. So you can see here's our cluster. Does it have the same name? Name. Yeah. So these things, they have the same name, but you have ARNs and whatnot. So no, actually, I was wrong. I was kind of thinking that you could just copy this one over. And now I'm not so sure. But anyways, we're good. We have this all sorted out. Yeah, the only thing that's a little bit tricky about doing all this infrastructure as management stuff is it can get very difficult to kind of keep track of which configurations go where. And that's why you want to be really careful when you're writing out your different configurations to really write tests, you know, like exactly like what I didn't do, but write tests to make sure that the intent of what you think is happening is actually happening. So for instance, one really good test could be for me to run this command and then to also run an additional kubectl get pods. Because for this, I'm saying, okay, deploy my infrastructure, deploy my Kubernetes cluster, run an update so that I can actually access that cluster. And then, oh yeah, by the way, once I've actually run the update so that I think that I can access that cluster, let me make sure I can actually update it. So a really good thing would have been to actually just write another command here and then just run kubectl get pods. If that didn't exit correctly, Terraform would have thrown an error and you would immediately know that something was wrong. So just, you know, so that I can kind of sit here and hammer home on some points. That's a good idea. Do it. Don't do what I did. Do as I say and not as I do, as I like to tell my kids. Okay. What are you complaining about? Here we go. I did the wrong thing. Okay, so again, now we're using Helm. Helm exists to help us with the application layer. Well, the application layer, the services layer, it helps with a couple different layers. All right. So, and there we go. Did that actually deploy? Like, no problem? Oh man, let's see this. Let's see. And now, let me just run a clear. Can I make this bigger? That's such a pain. Okay, so now when I run kubectl get pods, because Kubernetes is elastic, or Kubernetes on AWS is elastic, the pods are not always available. They're available on demand. So before, we said, at some point we said kubectl get pods, and it returned no resources found. Did I type that? Did I, like, Okay, I really think that earlier I typed kubectl get pods, and before we deployed the application, it said no resources found. Maybe I didn't, but I thought that I did. But that is because when I first deployed the Terraform cluster, when I first used Terraform to deploy the cluster, what happened is that it said, here's our cluster, but the pods are going to be on demand because it's an elastic cluster. And that's a lot of the benefit that you get of using AWS versus a data center, is that when you have a data center, normally what you do is you buy like physical computers, and those are always available. It's not elastic, they're not up or down on demand. That might be fine for you, that might not be. I'm going to imagine that if you're on AWS that you like all the elastic stuff. So that's what that is. Oh, and there we go, it's already running. So one thing that we're going to do, actually we're going to do clear, and then we're going to just run, we're going to run a couple of troubleshooting commands. So one really good one to get a lot of information is to run this kubectl describe. So kubectl describe, the resource type is pod, and then this is the ID. And this we got from doing kubectl get pods. So this is it, kubectl get pods, this is the name of the thing, we are describing this, and then kubectl describe pod, this big long thing here. Right, and then when I described it, it has so much stuff. It has all kinds of things that we don't really care about. But one thing that's really handy is if you are debugging something, if it's not running and you don't know why, probably something went wrong with starting your container, and it would hopefully be in here. It's not always going to be in here, but it will sometimes be in here. And then we are actually going to see if this was deployed as a service. So that was kubectl get svc. And you can see that this was deployed. It was deployed as a load balancer. This is pending. This is pending. I wonder how long this is going to take. Usually it's pretty fast, but the other day it took a while. Yeah, this took a little while. I don't know what else I can kind of rant about. What else can I talk about? Oh, regions. If you're using Terraform, don't do what I did. Be consistent about your regions. So one of the things that I normally do when I am using Terraform is I have an additional .aws file. Let me see if I can find you an example. Yeah. I have an additional .aws file, and I actually define all that stuff here. And I normally just tell it to use my current AWS region, which for me is US East 1. This initial file is like, it's a little bit strange because there are a few places where you can use variables and there are a few places that you can't. So you might end up kind of putting that in a couple places. But this is the file that it would look like if I had updated the basic example to use the backend, to use the AWS state. So you can see here. Yeah, this is the prefix, this is the prefix. Okay, and then I'm actually telling it Terraform backend. This is like the history file sort of Terraform, and I'm telling it use S3. And then I'm giving it all the examples, or not all the examples, all the data. So that's where that is. And you can actually see how this maps to, yeah, so you can actually see how this maps to a Terraform state. Sorry that this is in another project. That's a little bit aggravating. You can see I have my Terraform state, I initialize it over here, and then I reuse it for this project here. And that's all that happens, is it's a history, we're just keeping track of things, which is really, really nice when you have really big complex infrastructures. Another really nice point that I'll make about using something like Terraform is that you can also destroy everything all at once, which is very, very helpful. Because with AWS, if you just go in there, if you just go into the CLI and you start to try to destroy things, it's really not going to work out for you very well. At some point, you will clobber something because you will try to destroy something and it will depend on something else, and that thing will depend upon something else, and there will be this big, long, complex dependency tree. You don't want to have to resolve that by yourself. Once you get into complex infrastructure, really use CloudFormation, use Terraform. I'm sure there are other things out there. Use other things. Let's see. Is it ready? Is it ready? Is it ready? No, it's not ready. We'll try one more time. Okay, so this isn't ready. I'm gonna wait a little bit for this to come up, and when it comes up, I will restart the video. Bye-bye. And we're back. Okay, so before the service was taking quite a long time to deploy, and that was actually because I had a mistake, and I want to point out my mistake. So what I had was, okay, in the service, I had this session affinity, and I had it set to client IP. And this doesn't actually work with the type of ingress we're using. And if you need to know, I set this session affinity because, oh man, my brain just went completely blank there. I set it because with RShiny, when you have multiple replicas, you need to have sticky sessions enabled, or else it just starts to freak out. And that's because since it is like a data visualization application, it wants to make sure that the same users are going to the actual same application, or else things would get like very strange, right? They would refresh the page and then they would be in a different application and it wouldn't like save their state and all this kind of thing. So we have that. So instead of using client IP, we're just using cookie, which is, I don't know, for all intents and purposes, it's the same stuff. So we have the Nginx, Ingress, Kubernetes, Affinity, and we're using cookie. That's fine. If you wanted to keep this, oh, where did it go? If you wanted to keep this as client IP, just don't use the Nginx Ingress. Okay, I think that's getting way too involved in the services, those things. So I'm gonna have this here, and you can see how that works, and it will be posted too. Okay, so there we go. So then what I did is, because I upgraded this, I actually just reran this Helm command, and it upgraded, and it was fine. It was fine. I wonder if it'll be fine now. Now that I'm doing it in real time, we'll just have to see. Oh, so you see this? You see this kind of like niceness here, how my IDE, it has like the path. So I could go like this. I don't know. I just think that's a little bit nice that it does that. All right. Okay, and now we have an IP. Yay! Okay, it's not yay yet, and I'm gonna show you that. I was like, what is this? Why isn't this working? I shall go to Google. Okay, and you can see, oh, it is actually working. All right, I'm gonna show you another cool trick too. So here it is working, I guess because I had the video paused for a little bit longer than I thought. I'm not normally that patient when I'm checking my services. So anyways, you can see the welcome to the Shiny server. It is up here with what we have right here. So that's that. It's up. It's finally up after an hour. I checked the video. I couldn't believe that this was an hour of me talking. After an hour of me talking, finally, we have a Kubernetes cluster. We have an RShiny application that is deployed with Helm, and we have all manner of niceness. See? Look at this. It works. I was about to be like, does it work? Does it work? Yes, it works. Here we go. It works. There we go. Now, one other thing that you would want to do is if, you see here how we put like just all kinds of junk? We put a whole bunch of junk in here, right? Like things that don't actually make sense. When you deploy this, what you would want to do is that then you would want to go through and you would want to upgrade it. And if you remember earlier, I had discussed that everything in this values.yaml, you can actually, you can upgrade it from the CLI, or rather everything in the values.yaml is exposed through the CLI. So if we go and we look at this again, we'll see that one thing that we did was we actually exposed to the service type, and we exposed to this load balancer. Okay, we're gonna do this again. Okay, oh, man, typing. And we do this with this --set variable. So here I set the service type as a load balancer. I did this because I was on AWS. If you were on your own infrastructure, you would set this as a node port, and then you would have to do network configuration to make sure that you get a public IP. But let me show you. Okay, see, here it is. Service type. The default is cluster IP. Since I'm on AWS on a cloud provider, I'm using load balancer. And then another thing that I want to set is I want to set the ingress.hosts. And then if you go here, you see that this is, here's the host, and that this is an array. So you can actually access the things in your array. It starts with 0. I'm not going to touch this one. I'm actually going to touch this one. This is our AWS thing. This is what I want to update as the AWS. .host. Is equal to, and I want to set it as equal to this thing. And then I think if I do this, it's going to complain to me about the paths, but we're going to try this. Let's see. Does it complain about the paths? Yes, no, maybe so. What are you complaining about? Executing RShiny at host, nil pointer evaluating interface.host. Ingress.hosts 1. I don't know, maybe I do have to do 0. You see, now this is the trouble with coding in real time. Okay, see, so now it's, so I was like pointing at my screen as if you can see that. That is very useful to the YouTube world, huh? Anyways. And then we're going to do the same thing, ingress.hosts of 0, .paths. And then look, this got me for a little while. Paths is itself an array. So paths of 0 is equal to this. Yep. Is that going to work? Is it going to work? Is it going to work? Oh, there we go. And then you can actually see, okay, so then you'll get a nice note. And this also, it matters when you're doing it doesn't matter for this particular instance, but it matters when you are doing like real domain names. You want to make sure that you have that there. It will make it show up a little bit faster anyways. Sometimes it takes a little while. Like for this one, it showed up right away. And it showed up right away. And actually, it didn't show up right away. It's just that I deployed it. And then I started the video, and then I started talking, and then it was okay. If you really want for it to show up right away, you do this. Do I have an IDE anymore? I also realized I completely filled up my file storage. So that could potentially be why my computer was freaking out earlier. And there you go. Oh, this is kind of another thing that I wanted to point out about the Helm chart. Is that you can actually give notes. Like this is actually what it's called. It's called notes. And what it does is that it's just this little informational message that gets deployed at the end. So one of the things is that it will say it's deployed, it's revision, the notes, and then get the URL by running these commands. And that is because it knows that it's a load balancer, and then it goes through and it just like it gets all the stuff and it runs it, which is quite nice, because again, when you're working with these big complex systems, you are quite often going to be working with other people, and it's really easy to kind of get in your own head and be like, oh yeah, I know all this stuff in my head because I kind of worked through it. But it is quite nice. Like I really like the way that they did this, actually, that they have these notes there at the end. And back to my other point about how you would want to do this. So for instance, instead of having to do this Helm command, having to do all this manually, I have these programmed directly into my Helm charts, or not into my Helm charts, into my Terraform scripts. Helm, Terraform, SaltStack, CloudFormation, you know, there are so many things. Is this it? We're not gonna do this. We're gonna do this one, right? I think I screwed with like my default script, and that's not good. Oh, that's not good. Where's Helm? Helm. Is it not in this one? Okay, it's here. It's here in my template files. If it works. Because really, my storage is at like 99%. I don't know why these videos take so much space. They take a ridiculous amount of space. Once I've exported them to an MP4 or whatever export it is that I use, it's fine. But before that, it's something like this is going to be like 20 gigs. It's going to be something ridiculous. Is it gonna work? Oh man, all right, I wanted to show you. But so one of the things that I do personally is that every time I figure something out, so like I will go through and I will figure out this whole deployment, and then I will try to generalize it. Most of the time I'll try to generalize it a little bit. So for instance, very, very often I am deploying either RShiny, Flask, or Dash. These are the three things that I deploy most often in my work. And I deploy them, and quite frequently people want EFS storage as well. So I actually created myself a script that has templates of all these things, because you saw like going in there and actually manually modifying these files is, of course it's doable. Of course you can do it. But if you have a few things that you always deploy and you just need to change a couple of the variables, like I just throw these, I have template files for my templating systems, for my templating deployments. You know, it's like that. It's something, when I describe it like that, it sounds a little bit ridiculous. But anyways, this is a real world thing that I actually deploy. So you would see, you can just ignore the fact for a minute. This is it's a Jinja template. That's the kind of templating language that people use in Python. So you can actually see that I go through what I went through earlier, where, what do I do? Okay, so I actually run a dependency update with Helm. And then you can see I run Helm upgrade. So normally when I am doing this, I will actually put everything into the Terraform script, and that's because, or into the Terraform state, I don't know, whatever, into the Terraform configuration. And that is because it is really, really easy to forget how to do these things, or that I'm handing the project off to somebody else and that they may not know how to do these things, or that me in 2 minutes may not know how to do these things, you know, things like this. So if you actually have your whole process and it's documented from the very beginning to the very end, from deploying the cluster to deploying the application to updating it for your various ingress values. For instance, for this one, you know, what I actually do is I use Terraform to create EFS, which is the AWS networked file storage, and then I just refer to it here. So I don't have to go like digging around for the different variables, for the different IDs and things. I just use them all in here, which is a really nice aspect of using one of these infrastructure as code tools. So that's it. I will leave you with our pretty RShiny. Let me go like this one more time, and like this again, and like this again. Okay, that's it. If you actually watched this whole thing, thank you and have a nice day. Bye-bye.